All right, so we're going to start our ICND2 course talking about VLANs. Now, first, before you can truly understand VLANs, you have to understand the classic definition of a LAN, and a lot of you might think you know what it is. And when you see the classic definition, you'll say, oh, well, that makes sense. That's logical. The classic definition of a LAN is all devices that are in the same broadcast domain. Now, you'll recall from the ICND1 course that the broadcast domain is basically a group of computers that all listen to the same broadcast address. In this case, it's a layer 3 broadcast address. They listen to this broadcast address, and any information or any packets that are sent to that broadcast address is processed by every host on the LAN. Now, obviously, you can go buy a Cisco switch and you can plug all the devices into your switch. And if you need to add a second switch, you can just run a cable over to the secondary switch and start plugging in devices to that second switch, and your network can just kind of grow organically, which on a lot of small businesses, that's exactly what happened. We added a sales department down the hall, so we just ran a fiber cable down to the sales department and plugged it into another switch. And so now we've got 50 computers on our LAN instead of 35 or 40. And we're adding a research department down in the basement, so we're going to run some fiber down there. And if you don't give any thought to VLANs, then that means every time you add a switch, you're adding hosts to your broadcast domain. And if you ever just turn on Wireshark and look at everything that it captures, you'll see a lot of broadcasts going on, even on a very small network, such as your home network. You can imagine what those broadcasts look like on a network that has 50 and 60 and 100 and 125 computers in it. Well, VLANs are the answer to that. VLANs are a way of partitioning a switch, for lack of a better term, to reduce the broadcast domain. These partitions are called VLANs, and VLAN is an acronym for virtual LANs. They are virtual because you're not constrained by any physical limitations on the switch. If you have a switch that has 48 ports, you could have 48 VLANs, assuming that the switch software can handle it. Most modern ones can. And you could have every switch port be on its own VLAN, or you could divide it up into 3 different VLANs, and you could have internet and DMZ and internal network. Or you could have servers and workstations. Regardless of your overall VLAN mapping strategy, if you want to reduce the amount of data that's just flying around your network, VLANs are the way to do it. Now, most engineers, and myself included, I'm not anything special when it comes to this, they kind of equate a single VLAN with a single layer 3 network. And while that's true most of the time, when you get down to it and you get technical, VLANs are a layer 2 concept, and IP networks are a layer 3 concept. And so because of that, a single VLAN does not necessarily have to equate with a single layer 3 network. Now, for the most part, hosts in the same VLAN are usually in the same IP subnet. However, you can get some specialized configurations that span an IP subnet across multiple VLANs. Certain load balancers do this. You have a VLAN that's in front of the load balancer and a VLAN that's behind the load balancer, and the load balancer keeps the hosts from just bypassing the load balancer and going directly to the hosts behind it. Or you could have 2 VLANs and have a transparent bridge between the two, which a bridge is basically a 2-port switch, if you'll recall our discussions of switching in the ICND1 course. But again, for the most part, most hosts in a single VLAN are on the same layer 3 network. Even though that's the case most of the time, it is important to remember that it does not necessarily have to be the case. Now, given that most VLANs are their own layer 3 networks, if hosts are in different VLANs, they require a layer 3 device to get packets from one VLAN to another in most cases. Again, if you've got a transparent bridge or a load balancer, that's not necessarily the case, but we won't deal with all of those edge cases right now. So let's look at a little sample network here. Let's say you've got 3 machines all connected to a switch, and we'll assume that this is a layer 3 switch that can do IP routing. So each of these hosts are in their own VLAN, and as a result, each of these 3 hosts have a distinct IP address. Let's say this is 10.12.1.1, and this is 10.15.1.1. This would be 10.10.1.1 as an example. Now, since these 3 hosts are in different IP networks, if Al wanted to send some traffic to Ed over here, then Al would have to send his traffic through the switch This switch would then modify the layer 3 headers and send it over to Ed. Or if Ed wanted to send traffic to Tricia, it's the same general concept. Ed's traffic gets manipulated here in the layer 3 switch before it's sent over to Tricia. If Tricia sends a broadcast looking for a MAC address, for example, Al and Ed never see that broadcast because they are on different VLANs. They are on what is essentially a different physical network. And these VLANs are quite honestly just as separate as if they were connected to different physical switches with no connection at all between them. We'll pause here and we'll pick up with our VLAN overview in the next video.